Okay, the next thing, last concept we're going to talk about is logarithms. And again, everything you ever needed to know in math or everything you ever learned in math is going to come back up here. I'm going to show you the why of this, okay, because it's important to understand why. This is going to get into implicit differentiation, which we're going to deal with more often later on. But right now, you need to understand this is going to be one of those that's easier to memorize. If I say y is equal to ln x, that's really secretly log base e of x. And when we learned when we're dealing with logarithms, we also knew we could rewrite a log as an exponent by saying that that's e raised to the y is equal to x when you rewrite it in exponent form. And if I take the derivative of both sides, we know that the derivative of e to the y is going to be e to anything. So it'll be e to the y. And then the derivative times the derivative of the inside, which is going to be dy dx. And that's going to be equal to 1. Well, the problem is I need to solve for dy dx. So let me get a finer point then. So that's e to the y. So y is ln x. So that's e to the ln x times dy dx equals 1. Well, e to the ln x reduces to just become x. Dy over dx equals 1. So the derivative, divide the x over to the other side, is 1 over x. This is why this is true. So it's easier, obviously, to just memorize that the derivative of ln x is 1 over x. Okay, but of course it's never going to be that simple, so it's going to involve the chain rule. So in this case, it's ln of, let's see, do I want to do that one next? Or do I want to do something? I think I want to do a different example before I do this one. So I'm just going to break this up and say I want to do ln of 3x squared. Okay, that's going to be 1 over 3x squared, but we know that we want to, we also have to take the derivative of the inside, which is going to be 6x, and so that reduces to end up being 2 over x. Okay, that was a little weird, but if we think about this in terms of logarithms, that's ln of 3 plus ln of x squared. Okay, and all I've done is expand it, and I'm not even done expanding. That's ln 3 plus 2 ln x. Okay, now if I take the derivative of that, ln 3 is just a number, and the derivative of 2 ln x is going to be 2 over the derivative of ln x, which is x. So it's 2 over x. Okay, so with logarithms, it's frequently easier to expand first. Now this particular one doesn't expand, so this is going to be 1 over x squared plus 3 times 2x. Derivative of the inside. Chain rule is going to apply. All right, so we can do this the easy way, and we'll do it the hard way. So this is going to be 1 over x to the 5th times 5x to the 4th, because I need to do the derivative of the inside also. Well, when I look at that, that reduces to be 5 over x. Well, if I had remembered that y equals ln x to the 5th can be rewritten in its expanded form as 5 ln x, then I take the derivative, that's 5 over x. That's why, I mean, the chain rule has to apply. If you didn't apply the chain rule on this, you're not going to get the same answers. Two different ways to do the same problem. It is easier to expand your logs than take the derivative. Give you a further illustration of that is this looks like a nightmare, which, you know, yeah, it kind of is. But if I expand that first, that's ln of x squared minus 1 to the 1/2. And then remember, division is secretly subtraction, so that's minus ln of x plus 2 cubed. I'm going to move those powers to the front because your powers do get to fly to the front. Minus 3 ln x plus 2. All of a sudden, this problem is significantly easier to deal with because I've expanded first. Well, sorry, this is still, that's right. Okay, so it's going to be 1/2. The derivative of ln of x squared minus 1 is 1 over x squared minus 1 times the derivative of the inside, which is going to be 2x minus 3 over x plus 2, because the derivative of ln of x plus 2 is 1 over x plus 2. Going to clean up that 1/2 and 2, so this is x over x squared minus 1 minus 3 over x plus 2. That's what y prime equals. And I believe that is it for your video lessons. I hope that you guys did okay on this. Remember, you can check with Ms. Cheryl or Mr. Russell, and I will be back to answer any questions on Monday. Good luck.